Hello there, and welcome to this sleepy universe zone. There is a star so large that if you replaced our sun with it, the entire inner solar system would disappear before you even had time to understand what was happening. Mercury, gone. Venus, gone. Earth, everything you know, everything you've ever touched, already inside the star. And here is the part that should stay with you. That star is real. It exists right now, somewhere in the quiet darkness of our galaxy. Not imagined, not exaggerated. Real. Which means one simple thing. Your idea of big is not just slightly wrong. It is completely broken. Right now, as you're listening to this, wherever you are, maybe lying in bed, maybe letting your eyes slowly close, your mind is still holding on to familiar scales. You know how big a house is. You understand a city. You can even picture the Earth floating in space, and somewhere in your memory, the sun feels enormous, almost overwhelming. It lights your world, defines your days, and quietly powers everything around you. It feels like the ultimate reference point. But in the universe, the sun is not special. It is not large. It is not extreme. It is average in every possible sense. And that's exactly why this matters to you. Because everything you've ever imagined about size has been built on something that isn't actually big. So here's what we're going to do together, slowly, calmly, without rushing. We're going to take that familiar anchor, the sun, and gently move beyond it. Step by step, we'll explore how stars grow, why some expand into giants, and how a small number of them become so enormous that they begin to approach the limits of physics itself. You'll begin to understand why some stars can stretch hundreds, even thousands of times wider than the sun, and why, at a certain point, the universe itself starts to resist their growth. But more than that, this is not just about stars. This is about perspective, because as these scales expand, something else quietly shifts. The thoughts you brought into this moment, the tension, the noise, the small details that felt heavy, they begin to loosen, not because they disappear, but because they are placed into a much larger context. If this moment, right now, feels even slightly calming, you can gently support this journey so it reaches others who might need the same quiet sense of perspective tonight. Now here is something most people never realize. When you look up at the night sky, the brightest stars you see are not necessarily the biggest. In fact, many of the largest stars are so distant and often hidden behind clouds of dust that they appear faint, sometimes nearly invisible. Your eyes are not seeing size. They are seeing distance and brightness combined in a way that can be deeply misleading. The universe doesn't present itself honestly at first glance. It hides its extremes behind layers of scale and time. And that leads us to the real purpose of this journey. Over the course of this exploration, you're going to encounter stars that completely redefine what large means. Some will be hundreds of times wider than the sun. Others will be so vast that light itself, traveling faster than anything else in existence, it takes hours just to cross from one side to the other. And a few will sit so close to the theoretical limits of physics that they raise a quiet, unsettling question. How can something this large even exist without tearing itself apart? We will move carefully, step by step, from the familiar into the extreme. From stars you may have heard of, to ones hidden deep within our galaxy, to objects so unusual that they blur the line between observation and theory. By the end, you won't just understand how big the biggest stars are. You'll feel it in a way that stays with you. So take a slow breath in and let it go gently. There's nothing you need to do, nowhere you need to go. Just listen and allow your mind to drift a little further than it has before. Because the scale of the universe is already far beyond your imagination. You might think you understood how big a star can get, but the moment you try to compare them properly, something strange begins to happen. The numbers stop feeling real. A star can be 10 times bigger than the sun. That still makes sense. 100 times bigger. Still imaginable. But once you reach 1,000 times wider than the sun, your mind no longer stretches with the scale. It simply lets go. And that is exactly where the real story begins. Because size in the universe is not measured the way you might expect. Astronomers don't just say a star is big. They use a unit called a solar radius, which is simply the distance from the center of our sun to its surface. One solar radius feels familiar, but when a star is described as having 1,000 solar radii, it means you could line up 1,000 suns from center to surface across that star, not stacked inside, but stretched in a straight line. And even that description still hides something important. Because stars are not solid objects. They are vast, diffuse spheres of plasma, with outer layers so thin that they blur into space itself. Now imagine this slowly. If the sun were replaced by a red supergiant with a radius of several hundred solar radii, its outer atmosphere would extend beyond the orbit of Mars. Earth wouldn't just be close to the star, it would already be deep inside it. The sky would not be blue, it would not even be dark. It would be a constant, dim, glowing red, like being trapped inside an endless sunset. There would be no horizon, no edge, just a gradual thickening of light and heat as you move deeper into the star's atmosphere. And yet, even that is still not the upper limit. There are stars so large that their outer layers reach distances where planets like Jupiter would normally orbit. At that scale, something even stranger happens. The star itself becomes unstable. Its surface begins to pulse, expanding and contracting over time, like a slow, cosmic heartbeat. These pulses are not small. Entire layers of the star can move outward and inward across distances larger than the space between planets. Imagine a surface that breathes, not over seconds, but over years, even decades. Now here is where the physics becomes quietly fascinating. Stars exist because of a balance. The gravity pulls everything inward, while the energy from nuclear fusion pushes outward. As long as those two forces remain balanced, the star holds its shape. But when a star grows too large, that balance becomes fragile. The outer layers are held so loosely that they can drift away into space. In fact, many of the largest stars are constantly losing material, shedding vast clouds of gas that slowly expand into the surrounding darkness. This means something important. The biggest stars are not stable, long-lived giants. They are temporary, fragile, and often near the end of their lives. The larger the star becomes, the less time it has left. While our sun will live for about 10 billion years, the most massive stars burn through their fuel in just a few million years. a brief moment in cosmic time. And as you continue to listen, you may begin to notice a quiet shift in perspective. These stars, as enormous as they are not permanent. They expand, they struggle to hold themselves together, and eventually they collapse or explode. Their size is not a sign of stability. It is often a sign that they are nearing the end. There is also something deeply misleading about how we see them. A massive star that appears small in the sky may actually be far larger than a bright, nearby star. Distance hides size. And because light takes time to travel, the image we receive is always from the past. When you imagine a giant star, you are not seeing it as it is now, but as it was hundreds or thousands of years ago. Some of the stars we will explore may already be gone, their light still traveling toward us, it carrying a final image of something that no longer exists. So as we move forward, deeper into this quiet exploration, let yourself release the need to fully grasp the numbers. You don't need to calculate the size. You don't need to hold the scale perfectly in your mind. Just let the idea settle that the universe operates far beyond human intuition, that there are objects so vast they blur the line between structure and emptiness, between existence and disappearance. Take another slow breath and let it out gently, because in the next part of this journey, we will move from understanding size to confronting something even more unsettling. Stars that appear bright and powerful, but are quietly deceiving you. You might think the brightest star in the sky must be the biggest, but that assumption quietly collapses the moment you look closer, and the human eye is easily fooled, especially in the dark. A nearby light always appears stronger than a distant one, no matter how small it truly is. And the night sky is filled with this illusion, a carefully layered deception where distance disguises reality. When you step outside on a clear night and look up, one star often stands out more than any other. It burns with a sharp, steady brilliance, almost like a diamond suspended in the dark. For thousands of years, people believed that such a star had to be enormous. It seemed obvious. Something that bright must be something massive. But the truth is much quieter and far more interesting. That brightness does not come from size alone. It comes from proximity. Some of the brightest stars you see are relatively close neighbors in cosmic terms, only a few light years away. And their light has not traveled far, so it reaches your eyes with much of its original intensity still intact. Meanwhile, truly enormous stars that could swallow entire planetary systems, may sit thousands of light years away, their light stretched thin across vast distances, arriving as nothing more than a faint reddish glow. So the sky you see is not a map of size, it is a map of distance. This realization changes everything, because it means the most extreme objects in the universe are not the ones that immediately capture your attention. They are hidden, quiet, easy to overlook. You could spend your entire life looking at the night sky and never realize that the true giants are not the brightest points, but the faintest ones, barely visible at all. And there is another layer to this illusion. Light takes time to travel, even from nearby stars. It takes years. From distant giants, it can take hundreds, thousands, even tens of thousands of years When that light finally reaches you, it carries an image of the past, not the present. So when you see a distant star, you are not seeing what it is. You are seeing what it was. That means some of the stars you are quietly observing may have already changed or even disappeared entirely. Their light continues on, moving through space, unaware that its source has already transformed. You are looking at a delayed reality, a snapshot from a time long gone. And this creates a strange kind of calm, because it reminds you that everything in the universe unfolds slowly, far beyond the pace of human life. What feels immediate to you is, in the cosmic sense, just a brief moment. So as you listen, let that thought settle. And the brightest things are not always the biggest. The closest things are not always the most powerful. And what you see is never truly now. Because in the next step of this journey, we're going to move past the illusion of brightness and finally begin to encounter the true giants, the stars that remain hidden but hold sizes that quietly defy belief. There comes a point in a star's life when it begins to change, slowly at first, almost imperceptibly. Deep within its core, something shifts. The hydrogen fuel that has powered it for millions or billions of years begins to run low. The balance between gravity and energy, the quiet equilibrium that kept the star stable, starts to break. And when that balance changes, the star does something unexpected. It grows, and not a small expansion, not a gentle increase in size, but a dramatic swelling that transforms a star into something entirely different, a giant, then a supergiant, and in the most extreme cases, something even larger. At first, this might seem counterintuitive. You might expect a star to shrink as it runs out of fuel, but the opposite happens. As hydrogen in the core becomes scarce, the core begins to contract under gravity. This contraction increases the temperature and pressure in the surrounding layers, causing them to expand outward. The outer regions of the star inflate, stretching farther and farther into space. The result is a star that becomes enormous, but also cooler at its surface. That is why many of the largest stars in the universe glow with a deep red or orange color, and they are not cooler overall. Their cores are incredibly hot, but their outer layers have expanded so far that the energy spreads out, lowering the surface temperature. The light they emit shifts toward longer wavelengths into the red. These are the red giants, and beyond them, the red supergiants. Now imagine this carefully. A star that once resembled our sun, stable, contained, begins to expand until it reaches distances that were once occupied by planets. If our own sun follows this path, which it will in about 5 billion years, it will grow large enough to engulf Mercury and Venus, and possibly Earth itself. The place where you are now, the ground beneath you, could one day exist inside the outer layers of our own star. And yet, even that future version of the sun would still be considered modest compared to the largest known stars. And because some stars do not stop at a few hundred times the sun's size, they continue expanding, pushing past 1,000 solar radii, becoming so vast that their outer atmospheres are barely held together. At that scale, the star is no longer a sharply defined object. Its edges blur, its material drifts outward. It becomes something between a star and a cloud, a glowing, unstable presence in space. These stars pulse, they breathe, their surfaces rise and fall over time, driven by deep internal processes that are still not fully understood. Entire layers of gas move outward and inward in slow cycles, sometimes ejecting massive amounts of material into space. These ejections form expanding shells of gas and dust, the early stages of what may later become nebulae. And through all of this, the star is nearing its end. And because the larger it becomes, the faster it burns through its remaining fuel. Fusion reactions begin to involve heavier elements, helium, carbon, oxygen, each stage producing less energy than the last. The timeline shortens. What once took millions of years now takes thousands, then hundreds, then less. So when you imagine the largest stars, don't imagine permanence. Don't imagine stability. Imagine something vast, but temporary, something that has expanded to its limit and is now quietly approaching its final transformation. Take a slow breath and let it out, because in the next part of this journey, we will move beyond even these giants into stars so large that even calling them stars begins to feel insufficient. Just when you think a star has reached its limit, the universe quietly reveals something even larger, something that shouldn't be stable, and yet somehow still exists. These are not just giants, they are hypergiants, stars so vast that their own gravity struggles to hold them together. At this scale, the idea of a surface begins to lose meaning. The outer layers of these stars are so diffuse, so loosely bound, that they blur into space itself. If you could somehow approach one, you wouldn't encounter a clear boundary. There would be no sharp edge, no sudden transition from space to star. Instead, you would drift into a thinning cloud of glowing gas, slowly becoming denser as you moved inward. Now imagine something even more unsettling. The density in the outer layers of these stars can be lower than the air you breathe. In some regions, the gas is so thin that it would feel almost like a vacuum, despite being part of a star thousands of times larger than the Sun. These are objects defined not by solidity, but by scale. And yet, despite their enormous size, these stars are not particularly massive compared to their volume. A hypergiant might contain only 20 or 30 times the mass of the Sun, spread out across a space that could engulf entire planetary systems. This creates a strange imbalance. The star is huge but fragile. Its gravity is not strong enough to tightly bind its outer layers, and radiation from its core constantly pushes material outward. So the star begins to lose itself, slowly, continuously. It sheds vast amounts of gas into space. Stellar winds carry material away at incredible speeds, forming enormous envelopes of dust and plasma that surround the star. And over time, these outflows can create structures stretching trillions of miles, glowing faintly in the darkness. This process is not gentle, it is chaotic. The star pulses, its outer layers rising and falling in massive waves. Convection currents inside the star, each larger than the orbit of Mars, churn the material like a boiling ocean. When these currents reach the surface, they can trigger eruptions, throwing entire shells of gas into space. Now here is the quiet contradiction. The bigger the star becomes, the closer it is to falling apart. There is a fundamental limit in physics. often called the balance between gravity and radiation pressure. Gravity tries to pull the star inward, while the energy from fusion pushes outward. In smaller stars, gravity wins easily. But in hypergiants, the outward pressure becomes so strong that it nearly overcomes gravity entirely. The star exists on a knife's edge. Any increase in energy, any instability, can push the balance too far. When that happens, the star responds by ejecting mass, shedding its outer layers to reduce the pressure. It is, in a sense, trying to survive by slowly tearing itself apart. And this is why these stars feel so strange. They are not stable objects quietly existing in space. They are temporary, transitional, caught in a brief and violent phase of stellar evolution. Their enormous size is not a sign of strength, but of instability. As you listen, you may begin to feel a quiet shift in how you imagine them. Not as solid spheres of fire, but as vast, breathing structures, constantly changing, constantly losing pieces of themselves to the surrounding void. And take a slow breath in and let it go gently, because the next step in this journey moves even further beyond intuition, to a place where size itself becomes difficult to define, where the biggest stars ever measured push against the very limits of what the universe allows. There is a point in the universe, an invisible boundary, where stars can no longer grow larger without destroying themselves. You cannot see this boundary. You cannot travel to it. But every massive star eventually feels its presence. This is not a physical wall, but a limit defined by the laws of physics themselves. At the heart of every star, nuclear fusion produces an enormous amount of energy. This energy travels outward, pushing against the star's outer layers. In smaller stars, this outward push is balanced by gravity pulling inward. But as a star becomes more massive and more luminous, the outward force grows stronger until it begins to rival gravity itself. This balance point is known as a fundamental limit, the threshold where radiation pressure equals gravitational pull. And beyond that point, a star cannot hold itself together. If a star tries to grow larger, tries to produce more energy, the outward pressure will exceed gravity and the outer layers will be blown away into space. The star physically cannot maintain a larger size. It sheds mass until the balance is restored. This means something profound. There is a maximum size that normal stars can reach, and many of the largest stars we know sit right at that boundary. They are not comfortably stable objects. They are barely holding themselves together, constantly losing mass, constantly adjusting, always on the edge of disruption. Their size is not arbitrary. It is defined by a precise and delicate balance between two opposing forces. Now imagine this in a quiet, intuitive way. A star expands, growing larger and larger until the pressure from its own light becomes so strong that it begins to blow itself apart. At that moment, the universe says, "No further." This is why the largest stars we observe tend to cluster within a certain range. They may vary in size, pulse over time, expand and contract, but they rarely exceed a certain scale. Not because larger stars are impossible in theory, but because they cannot remain stable long enough to be observed. They destroy themselves too quickly. And yet, even within this limit, the sizes reached are beyond anything you have ever experienced, is stars that stretch across distances larger than the orbit of Jupiter, stars whose light takes hours to cross their diameter, stars so vast that their own structure becomes diffuse and uncertain. But here is where the story becomes even more interesting, because this limit applies to stars as we understand them today, formed from material enriched by previous generations of stars. In the early universe, when the first stars were born, conditions were different. The rules may have allowed for objects even larger, even more extreme. So as you rest here, letting your thoughts drift, consider this gentle idea. The stars we are exploring, as enormous as they are, may not even represent the true upper limit of what once existed. Take another slow breath and let it out, because in the next part of this journey, we will move beyond modern stars and begin to explore objects from a time when the universe itself was younger and far more extreme. There is something quietly unsettling about the largest stars in the universe, not just their size, but the fact that many of them may no longer exist. As you listen to this, imagine a star thousands of times wider than the sun, glowing faintly in the distance, holding itself together at the very edge of physical possibility. Now imagine that star exploding, collapsing, or fading away centuries ago, and yet tonight you can still see it. Because light takes time to travel, the universe does not show you what is happening now. It shows you what has already happened. This means that every massive star you imagine, every giant, every hypergiant, is part of a delayed reality. The farther away the star is, the older the image becomes. A star 1,000 light years away appears to you as it was 1,000 years ago. A star 20,000 light years away shows you a moment from a time before modern civilization even began. And when you start looking at the largest stars, the ones scattered across distant regions of the galaxy, you are often looking deep into the past. Now, let that idea settle slowly. The sky above you is not a snapshot of the present. It is a layered memory, a collection of moments stretched across time. Some stars you see are relatively recent, their light only a few years old. Others are ancient, their light beginning its journey long before human history was written. And among them, there are stars that have already ended their lives, leaving behind nothing but the light still traveling towards you. This creates a strange kind of perspective, because when you think about the largest stars, you are not just thinking about size, you are thinking about time. These stars burn fast. They live short, intense lives compared to smaller stars like our sun. While the sun will exist for around 10 billion years, the most massive stars may only last a few million years, or even less. That means by the time their light reaches you, they could already be gone. Some may have exploded in supernovae, releasing more energy in a few seconds than the sun will produce over its entire lifetime. Others may have collapsed into black holes, leaving behind regions of space where gravity is so strong that not even light can escape. And yet, from your perspective, they still shine quietly in the sky. You are looking at echoes. There is something calming about this, once you allow yourself to feel it. The universe moves slowly, but it also preserves its past. Nothing disappears instantly. Even the most violent events, the death of a star, unfold in a way that leaves traces behind. Light carries the story forward, crossing unimaginable distances, delivering it gently to anyone who happens to be looking. So as you continue this journey, you are not just observing stars, you are observing history. Each point of light is a message, a signal that has traveled for years, centuries, sometimes thousands of years, just to reach you in this moment. Take a slow breath and let that thought settle, because the next step takes us deeper into the life of these stars, into the moment where their size, their instability, and their short lifespans converge, leading to one of the most powerful events in the universe. At some point, no matter how large a star becomes, no matter how long it has held itself together, there comes a moment when the balance finally breaks. It does not happen slowly. It does not give warning in a way you could easily recognize. It happens deep inside the core, far beyond anything you could ever see. And when it begins, it is already too late. Inside every massive star, layers of fusion occur like nested shells, and hydrogen fuses into helium, helium into carbon, carbon into heavier elements, each stage producing less energy than the last. As the star ages, it builds a complex internal structure, with different elements fusing at different depths. This process continues until one final element forms in the core. Iron. Iron is different. When a star tries to fuse iron, it does not release energy. It absorbs it. That means the core suddenly loses the ability to support itself against gravity. The delicate balance that has held the star together for millions of years collapses in an instant, and gravity takes over. The core implodes, collapsing inward at incredible speed. In less than a second, it compresses to extreme densities, reaching conditions found nowhere else in the normal universe. The outer layers, suddenly unsupported, begin to fall inward as well. Everything moves toward the center, faster and faster, until something extraordinary happens. The collapse stops and reverses. The inner core becomes so dense that it resists further compression, creating a rebound effect. A shockwave forms and races outward through the star. As it travels, it tears through the collapsing layers, blasting them into space with unimaginable force. This is the moment of explosion, the moment a supernova is born. For a brief time, a single star can outshine an entire galaxy. Now imagine this quietly. A star that once stretched across planetary orbits, a star so large that light took hours to cross it, ends its life in a flash that lasts only weeks or months. All that size, all that structure, all that time compressed into a single violent event. And the outer layers are expelled at speeds of thousands of kilometers per second, forming an expanding cloud of gas and dust. This cloud, glowing and evolving over time, becomes a supernova remnant, a vast structure that can persist for tens of thousands of years. Inside it, at the center, something remains. Sometimes it is a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. Other times, if the original star was massive enough, the core continues collapsing until it forms a black hole, a region where gravity becomes absolute, and in some rare cases, the explosion is so powerful that nothing remains at all. The entire star is completely destroyed, every atom scattered into space. But even in destruction, something important happens. The elements forged inside the star, carbon, oxygen, silicon, iron, are released into the surrounding space. These elements mix with interstellar gas, becoming part of future stars, future planets, even future life. The atoms in your body, the iron in your blood, the oxygen you breathe, were created in stars like these long before the Earth existed. So as you rest here, listening quietly, you are connected to these stars in a very real way, not just through observation, but through origin. Take another slow breath and let it out gently, because in the next part of this journey, we will move beyond the life and death of individual stars and begin to explore something even more extreme, objects that existed in the early universe, when the rules themselves were different, long before the stars we've been imagining, long before red giants, supergiants, and hypergiants filled the galaxy. The universe was a much simpler place. No planets, no heavy elements, no complex structures, just vast clouds of hydrogen and helium, slowly drifting through darkness. And yet, within that simplicity, something extraordinary was about to begin. The first stars. But these were not like the stars you know today. They formed under very different conditions, in a universe that had not yet been shaped by previous generations of stellar life. There were no heavier elements to help cool the gas, no dust to guide the collapse. The raw material was pure, and because of that, the process of star formation changed in a fundamental way. The gas clouds could not fragment easily. They stayed hotter for longer, resisting collapse until they reached enormous sizes. And when they finally did collapse, they didn't form small or medium stars. They formed giants. These first-generation stars, often called population 3 stars, are believed to have been far more massive than most stars we see today. Some estimates suggest they reached tens, hundreds, even up to 1,000 times the mass of the Sun. And with that mass came incredible luminosity and extreme temperatures. Imagine a star so bright that it floods its surroundings with intense ultraviolet radiation, stripping electrons from atoms, transforming the structure of the universe itself. These early stars did not just shine, they reshaped the cosmos. Their light began a process called rionization, turning the universe from an opaque fog into something transparent, something that could carry light across vast distances. Like without them, the universe would remain dark. But here is the quiet paradox. The bigger these stars were, the shorter their lives became. With such enormous mass, their cores burned at incredible rates, consuming fuel far faster than smaller stars ever could. While the Sun lives for billions of years, these early giants may have lasted only a few million years, brief flashes in cosmic history. And when they died violently. Some exploded in massive supernovae, scattering the first heavy elements into space. Others may have undergone even more extreme events, completely destroying themselves without leaving any remnant behind. These explosions seeded the universe with the building blocks of everything that came later: planets, oceans, and eventually life. So as you rest here, listening quietly, consider this gentle idea. In the largest stars you can imagine today, may not even compare to what existed in the beginning. There was a time when the universe itself allowed for even more extreme objects. Stars that lived fast, burned bright, and disappeared almost as quickly as they formed. take a slow breath in and let it out, because what comes next is even stranger. Objects that blur the line between stars and something far more mysterious. There are moments in science where imagination and theory begin to overlap, where the universe seems to hint at possibilities that feel almost impossible and yet remain grounded in physics. One of those possibilities is something known as a quasi-star, an object so unusual that it challenges what we even mean by the word star. Imagine a star, not powered by fusion at its core, but by something else entirely. At the center of a quasi-star, instead of a stable fusion region, there is a black hole, not a remnant, not something formed after the star's death, but an active, growing black hole, embedded inside the star itself. Surrounding it is a vast envelope of gas, hydrogen and helium, extending outward across enormous distances. From the outside, it may look like a star, glowing, massive, stable. But inside, something very different is happening. Matter is falling inward, spiraling toward the black hole. As it does, it heats up, releasing enormous amounts of energy. This energy pushes outward, supporting the outer layers of the star against collapse. In a sense, the black hole becomes the engine, replacing fusion as the source of pressure that holds the structure together. Now imagine the scale of such an object. And because the energy source is so powerful, the outer envelope can expand far beyond the limits of normal stars. Some models suggest quasi-stars could reach sizes tens of thousands of times larger than the Sun. At that scale, they would not just engulf planetary orbits, they could swallow entire solar systems. The distances inside such an object become almost impossible to comprehend. Light would take days, perhaps even longer, to cross from one side to the other. The structure would be so vast that different regions might behave almost independently, like separate environments within the same object. And yet, these objects would not last long. As the black hole at the center grows, it consumes more and more material. Over time, the energy output increases, destabilizing the outer layers. Eventually, and the envelope is blown away, leaving behind a much larger black hole, free in space. This process may explain something that has puzzled astronomers for years: the existence of supermassive black holes in the early universe, objects with millions or even billions of times the mass of the Sun, appearing far earlier than expected. Quasi-stars provide a possible path, allowing black holes to grow rapidly inside these massive structures before emerging. Now take a moment to let this settle. A star, with a black hole at its center, growing from the inside out, expanding to scales far beyond anything we observe today, and then disappearing, leaving behind one of the most extreme objects in the universe. It is quiet, it is strange, and it reminds you of something deeper, that the universe is not limited to what feels intuitive. It is not constrained by what seems reasonable. It explores every possibility allowed by physics, even those that blur the boundaries between categories we thought were clear. So as you continue drifting through this journey, allow your mind to stay open, soft, unhurried, because the next step moves even further into the unknown, toward objects that may have been larger still, powered not by fusion, not by gravity alone, but by something we still barely understand. There is something in the universe that you cannot see, cannot touch, and yet it outweighs everything you know. Galaxies rotate too fast to be held together by visible matter alone. Clusters of galaxies bend light in ways that cannot be explained by stars or gas. Something else is there, something invisible. Scientists call it dark matter. And while we still do not fully understand what it is, there is a quiet possibility that in the early universe it may have created something extraordinary. Stars that were not powered by fusion, but by dark matter itself. Imagine a vast cloud of hydrogen and helium, similar to the ones that formed the first stars, but embedded within a region where dark matter is unusually dense. As gravity pulls the gas inward, dark matter particles collect at the center. If certain theoretical conditions are met, those particles can interact, collide, and annihilate each other, releasing energy in the process. This energy does something unusual. It heats the surrounding gas, not through nuclear fusion, but through a completely different mechanism. And that heat pushes outward, resisting gravity, holding the star together. And now imagine what happens next. Because this form of energy is gentler, slower. It does not require the same extreme temperatures as fusion. The star does not need to compress itself tightly. It can expand, becoming larger and larger without collapsing under its own weight. Some models suggest that these dark stars could grow to sizes far beyond any normal star, reaching millions of times the radius of the Sun. At that scale, the concept of a star begins to dissolve. A dark star could stretch across distances so vast that it would engulf not just planets, but entire regions of space where multiple stars might otherwise exist. The space between stars in a galaxy, the distances we usually consider immense, could fit inside a single object. Its surface would be cool compared to typical stars, but glowing softly, almost gently, despite its immense size. And unlike hypergiants, which live fast and die quickly, these objects might have lived for much longer. As long as the dark matter fuel remained available, the star could persist, slowly radiating energy, quietly dominating its region of space. But like everything in the universe, it would not last forever. Eventually, the supply of dark matter would diminish, the energy source would weaken, and without that support, gravity would begin to take over. The star would contract, heating up, transitioning into a more conventional phase, or collapsing inward. In some cases, this collapse could form a black hole, one already massive from the beginning, providing a seed for the enormous black holes we observe at the centers of galaxies today. Now pause for a moment and let this idea settle. A star, powered by something invisible, growing to sizes beyond comprehension, lasting far longer than ordinary stars, and then quietly collapsing into one of the darkest objects in the universe. It feels almost like a story from imagination, and yet it emerges naturally from the equations that describe how matter and energy behave. We have not observed a dark star directly, but the possibility remains, waiting somewhere in the deep past of the universe, hidden in the light that has not yet reached us. Take a slow breath and let it out gently, because the next step in this journey asks a deeper question. Not just what has existed, but what could exist. If every limit were pushed to its edge, at some point, as you continue listening, a quiet question begins to form. If stars can grow this large, if hypergiants stretch across planetary orbits, if quasi-stars and dark stars can expand even further, then where does it stop? Is there a final limit? Or could something grow so large that it swallows entire systems, perhaps even more? To answer that, you have to step back and think about what a star really is. A star is not just a glowing object. It is a balance. Gravity pulling inward, energy pushing outward. That balance defines its size, its structure, and its lifespan. If gravity dominates too much, the star collapses. If outward pressure becomes too strong, the star expands and may eventually lose its outer layers. So the size of a star is not arbitrary. It is controlled by the physics of this balance. For stars powered by fusion, there is a clear limit. As mass increases, the energy output rises dramatically. Beyond a certain point, radiation pressure becomes so intense that it begins to blow material away faster than gravity can hold it. This sets an upper boundary on how massive and how large a stable star can be. That is why the largest known stars tend to cluster within a certain range, thousands of times the Sun's radius, but not endlessly larger. They approach the limit, but rarely exceed it for long. If they do, they quickly shed mass, returning to a more stable state. But when you move beyond fusion, when you consider objects like quasi-stars or dark stars, the situation changes. Because the energy source is different, the constraints shift. A black hole feeding at the center can generate enormous energy without requiring the same internal structure as a normal star. The dark matter's annihilation can provide a steady, low-intensity source of heat that allows the object to expand without collapsing. Under these conditions, the theoretical size can increase dramatically. Some models suggest quasi-stars could reach tens of thousands of solar radii. Dark stars, under the right conditions, could grow even larger, potentially reaching sizes that stretch across entire stellar neighborhoods. At that scale, the object is no longer just a star in the traditional sense. It becomes something more like a vast, diffuse region of energy and matter, held together loosely, barely maintaining coherence. And here is where physics quietly pushes back again. Because as an object grows larger, communication across it becomes slower. Light takes longer to travel from one side to the other. Pressure waves, energy transport, all of it becomes delayed. Eventually, the object becomes too large to behave as a single unified structure. It begins to fragment or collapse or transform into something else. So even in theory, there is a practical limit, not a sharp boundary, not a single number, but a region where structure gives way to instability, where size becomes less meaningful, where the object can no longer function as a star in any coherent sense. Now let that idea settle quietly. The universe allows for enormous structures, far beyond what you can easily imagine, but it also imposes limits, not out of restriction, but out of balance. Every extreme pushes against something else. Every expansion meets resistance. And within that tension, the shapes of stars, of galaxies, of everything you see are defined. Heck, take another slow breath and let it go. Because as this journey continues, we will return from theory back to observation and look again at the largest stars we know today with a deeper understanding of what they truly represent, not just in size, but in the delicate balance that allows them to exist at all. Now that your mind has drifted through the extremes, through ancient stars, invisible matter, and objects that blur the definition of what a star even is, we return gently to something quieter, the largest stars we can actually observe today. And as you come back to them, something feels different, because now you don't just see them as big, you understand how close they are to falling apart. Imagine again a red supergiant, vast, glowing softly in deep shades of orange and red. Its outer layers extend across distances larger than the orbits of planets, its structure loose, almost fragile. But now you know what holds it together and how delicate that balance truly is. Gravity pulling inward, radiation pushing outward, always on the edge. These stars are not static. They change, slowly, subtly, but constantly. Their surfaces rise and fall in enormous convection currents, each one larger than entire planetary systems. Hot gas moves upward from deep inside the star, cools, and sinks back down. This motion creates a surface that is uneven, dynamic, almost alive in its movement. If you could observe it closely, you would not see a smooth sphere, but a shifting landscape of glowing regions, expanding and contracting over time. And then there are the pulses. Some of the largest stars expand and contract rhythmically, not over seconds or minutes, but over months, years, even decades. Their brightness changes as their size changes. Their outer layers move outward, then fall back inward, like a slow, breathing motion on a scale that defies intuition. Now imagine standing on a distant world, orbiting such a star. The sky would never feel stable. The light would subtly change over time. The star might grow larger in the sky, then smaller. Over the course of years, shadows would shift, not just with the rotation of a planet, but with the star itself evolving. And surrounding many of these stars, there are vast clouds of material, gas and dust that has been shed over time. These clouds drift outward, forming enormous envelopes that can extend for trillions of miles. They glow faintly, illuminated by the star's own light, creating structures that are both beautiful and transient. These are not just remnants. They are part of the star's ongoing story, because every time the star pulses, every time instability builds, it loses a little more of itself. Slowly, quietly, it is preparing for its end. Take a slow breath and let that thought settle. These stars, as massive as they are not permanent. They are passing through a brief phase, a moment where they appear at their largest just before everything changes. And now, with this understanding, the next step becomes clearer. Because if size is tied to instability, and instability leads to collapse, then the largest stars are not just the biggest. They are also the closest to something final. At first, size feels like power. A larger star seems stronger, more dominant, more significant. But as you continue to drift through this understanding, that idea begins to shift. Because in the universe, size often means something else entirely. It means time is running out. The largest stars burn their fuel at incredible rates. Their cores are hotter. their fusion processes more intense, their energy output far greater than smaller stars. And because of that, they live fast. What takes the Sun billions of years, these stars complete in a fraction of the time. A hypergiant may live for only a few million years. In cosmic terms, that is almost nothing. And as the star approaches the end of its life, the signs begin to appear. The pulses become stronger. The mass loss increases. The outer layers drift farther into space, and the balance between gravity and radiation becomes more unstable. Each change is subtle on a human timescale, but inevitable on a cosmic one. Now imagine this gently. A star expanding, reaching its maximum size, glowing softly in deep red light, while deep inside, the core is changing. Heavier elements begin to fuse, the energy output shifts, the structure becomes more complex, more fragile, and with each step, the star moves closer to a point where it can no longer hold itself together. There is no dramatic warning, no sudden signal that can be seen from a distance, just a quiet progression toward instability. And then, at some moment, you could never predict precisely, the balance breaks. What follows is not gradual. It is not slow. It is a transformation that happens in seconds. After millions of years of build-up, the star collapses, rebounds, and releases its outer layers in an explosion that briefly outshines entire galaxies. But before that moment, there is stillness, a calm, almost peaceful phase, where the star appears stable from the outside, even as its core moves toward collapse. This is the stage many of the largest stars you can imagine are in right now. They glow softly, quietly, holding themselves together for just a little longer. And as you rest here, listening, you are connected to that moment. Not directly, not in a way that affects your daily life, but in a deeper sense. You exist in the same universe, shaped by the same processes, built from the same elements that these stars are still creating. Take another slow breath and let it out. Because as we continue, we will move closer to the final question. Not just how big stars can become, but what remains after they are gone, and how those remnants shape everything that comes next. When a star finally reaches the end, when all the expansion, the instability, the quiet struggle between gravity and light can no longer continue, something remains. Not the star as you imagined it, not the vast glowing sphere stretching across space, but something far smaller and far stranger. It's easy to think of the end of a star as disappearance. A bright object fades, explodes, and is gone. But in the universe, nothing truly vanishes. It transforms. The largest stars do not simply end. They change form, leaving behind remnants that continue to exist long after the original star is gone. Imagine the moment just after the explosion, and the outer layers of the star have been thrown into space, expanding outward in a glowing cloud. This cloud will continue to grow for thousands of years, slowly cooling, slowly fading, becoming part of the interstellar medium. But at the center, where the core once resisted gravity for millions of years, something compact remains. If the original star was massive, but not too extreme, the core compresses into a neutron star. This is an object so dense that matter behaves in ways that are difficult to imagine. Protons and electrons merge into neutrons, creating a structure where the usual atomic boundaries no longer exist. The entire mass of a star compressed into a sphere no larger than a city. Now pause for a moment and let that contrast settle. In a star that once stretched beyond planetary orbits, reduced to something small enough to fit inside a landscape you could cross in a few hours, and yet its gravity remains immense. If the star was even more massive, the collapse does not stop there. Gravity continues to compress the core beyond the point where even neutron matter can resist. The result is something even more extreme: a black hole, a region where gravity becomes so strong that not even light can escape. From the outside, it appears quiet, invisible, but its presence is undeniable. Matter that comes too close is drawn inward, accelerated, heated, and eventually disappears beyond the event horizon, the boundary where return is no longer possible. And here is the quiet truth. As some of the larger stars you've imagined, the ones that stretched across vast distances, have already ended this way. Somewhere in the galaxy, there are black holes that were once enormous stars, glowing, expanding, before collapsing into silence. Take a slow breath and let it go. Because even in this transformation, something continues. The death of a massive star is not just an ending, it is also a beginning. When the outer layers are expelled into space, they do not simply drift away without purpose. They carry with them something essential, something that did not exist before the star lived. Elements. Inside massive stars, nuclear fusion creates heavier and heavier elements over time. Hydrogen becomes helium. Helium becomes carbon. Carbon becomes oxygen. And so on, building up a rich internal structure of matter. And during the final explosion, even heavier elements can form: iron, gold, uranium. Elements that require extreme conditions to exist at all. These elements are scattered outward, mixed into the surrounding gas, becoming part of the galaxy itself. Now imagine this quietly. A cloud of gas expanding slowly through space, enriched with the material from a long dead star. Over time, gravity pulls parts of this cloud together. It begins to collapse, forming new stars, new systems, new planets. And within those planets, the same elements begin to assemble into something more complex: rocks, water, atmospheres, and eventually, life. The iron in your blood, the oxygen you breathe, the carbon that forms your body, all of it was created inside stars like the ones you've been imagining, not recently, but billions of years ago. Before the Earth existed, before the sun formed, before anything you recognize was present. You are not separate from these stars. You are made from them. And this connection is quiet, subtle, but constant. Every breath you take carries atoms that were once part of something vast, something luminous, something that lived and died long before you were here. Now let that idea settle gently. The largest stars, the ones that stretch your imagination, are not just distant objects. They are part of a cycle, a process that shapes everything in the universe. They grow, they expand, they collapse, and in doing so, they create the building blocks for everything that follows. Take another slow breath and let it out, because as we continue, the journey will shift again from what remains to something even more profound, the realization that the search for the biggest star may never truly end. Even after everything you've heard, after the giants, the hypergiants, the limits of physics, the strange objects of the early universe, there is still one quiet truth left to face. We may never find the biggest star, not because it doesn't exist, but because the universe is too vast, too filled with hidden corners, too layered with distance and dust and time. Our galaxy alone contains hundreds of billions of stars. Many of them are obscured behind thick clouds of gas and dust that block visible light. Others sit so far away that their details blur into a single point, their true size hidden behind the limits of our instruments. And beyond our galaxy, there are billions more, each one with its own population of stars, its own history, its own extremes. Somewhere among them, there may be stars larger than any we have ever measured, stars that stretch closer to the limits of what physics allows, stars that form under unusual conditions, grow in isolation, and remain unseen simply because their light has not yet reached us, or cannot reach us clearly. So the idea of the biggest star becomes something different, not a single object, not a fixed record, but a moving boundary, a shifting edge of knowledge that expands each time we look deeper, measure more precisely, or discover something new. There have been moments in astronomy where a star was believed to be the largest known, only for that estimate to be revised later. Measurements improve, distances are recalculated, dust clouds are better understood, and with each refinement, the size changes. A star that once seemed impossibly large becomes slightly smaller, or occasionally, even larger than expected. The uncertainty is not a flaw, it is part of the process, because measuring something so distant, so diffuse, so constantly changing is not simple. The outer layers of these massive stars are not sharply defined. They expand and contract. They lose material. Their edge is more like a gradient, a slow fading into space. So when astronomers calculate their size, they are often working with models, approximations, best estimates built from light, temperature, and distance. And that means the leaderboard is never stable. Now let that idea settle gently. The biggest star you can name, the one that seems to hold the record, may not always remain the largest. Somewhere, quietly, beyond our current observations, something bigger may already exist, waiting to be discovered, or perhaps already gone. Its light still traveling toward us. Take a slow breath and let it out, because the search itself is part of the wonder. As you continue drifting through these ideas, something subtle begins to happen. The numbers grow larger, the distances stretch further, the scales become more extreme, until eventually, your mind begins to soften its grip. It stops trying to hold everything precisely. And that is not failure, that is understanding. Because the universe is not meant to be fully contained within human imagination. It extends far beyond the limits of what the brain evolved to process. And when you try to picture a star thousands of times larger than the sun, or a structure so vast that light takes hours to cross it, you are reaching the edge of what can be visualized. Beyond that edge, there is only approximation. You can describe it, you can calculate it, you can compare it to things you know, but you cannot fully feel it in the same way you feel the size of a room or a landscape or even a planet. And yet, something still connects, not through precise images, but through awareness. A quiet recognition that there are scales of existence far beyond your daily experience, that the universe contains structures so vast, so distant, that they unfold almost independently of anything you do, or think, or feel. And instead of creating discomfort, this realization often brings calm. Because when you step back far enough, when your perspective expands beyond immediate concerns, the details that once felt overwhelming begin to lose their intensity. Not because they disappear, but because they are placed into a much larger context. The universe does not rush. Stars take millions of years to grow, to expand, to reach their final stages. Galaxies evolve over billions of years. Even light, traveling faster than anything else, takes thousands of years to cross the distances between the largest objects. Everything moves, but slowly. So as you rest here, listening, there is no need to hold on to every detail, no need to visualize every scale perfectly. You can let the ideas drift, just like the stars themselves, existing quietly in the background of your awareness. Take another slow breath and let it go. Because what matters is not that you fully imagine the largest star, but that you allow yourself to feel the space it exists within. And in that space, there is something peaceful, a sense that the universe is vast, steady, and unhurried, and that you are simply a part of it. There is something quietly humbling about the idea of distance in the universe, not just how far things are, but how long it takes for anything to travel between them. Even light, moving faster than anything else that exists, does not arrive instantly. It moves steadily, patiently, carrying information across the darkness, one moment at a time. Now imagine a star so distant that its light began its journey before modern history was written, before cities rose, before nations formed, before entire generations lived and passed. And that light has been traveling ever since, crossing space without stopping, without slowing, until finally, tonight, it reaches you. You look up and you see it, but what you are seeing is not the present. It is a message from the past. And when it comes to the largest stars, this delay becomes even more profound. Many of the giants we've been imagining are located thousands, sometimes tens of thousands, of light years away. Their light left them long before your current world existed. What you see now is only a record, a snapshot, frozen in time. This means something subtle, but important. Some of the biggest stars you can imagine may have already changed. They may have collapsed, exploded, or faded into something else entirely. And yet, their light continues forward, still carrying the image of what they once were. Yet you are not looking at a star, you are looking at a memory. Now let that idea settle slowly. Every point of light in the sky represents a different moment in time. Some are recent, just a few years old. Others are ancient, carrying information from centuries or millennia ago. And when you consider the largest stars, the most distant ones, you are reaching back into deeper layers of history. The sky is not a single moment. It is a collection of moments, all arriving at once. And within that collection, the largest stars exist as quiet echoes. Their true state hidden behind the time it takes for their light to reach you. Take a slow breath and let it out gently. And because in the next step, we move from distance and time into something even more subtle, the realization that even light itself can be distorted, shaped by the structure of the universe. You might imagine space as empty, a simple void where stars exist and light travels in straight lines. But in reality, space is not flat, and it is not passive. It bends, it curves, it responds to mass and energy in ways that quietly reshape everything you see. This means that when light travels across the universe, it does not always follow a straight path. As it passes near massive objects, stars, clusters of stars, even entire galaxies, the fabric of space itself curves around those objects. And as space curves, the path of light curves with it. This effect is known as gravitational lensing, and it creates one of the most fascinating illusions in the universe. Light can be magnified, it can be stretched, duplicated, even bent into arcs and rings. Now imagine this carefully. A distant star, far beyond what you could normally detect, emits light in all directions. That light begins its journey, traveling across space. Along the way, it passes near a massive object, perhaps a cluster of galaxies. The gravity of that cluster bends space, and the light is redirected, focused, amplified. By the time it reaches you, it appears brighter than it should be. In some cases, much brighter. This means that some of the stars we observe, especially the distant, massive ones, are being subtly enhanced by the universe itself. And their light is not just traveling to us, it is being shaped along the way. And this introduces another layer of complexity, because now brightness becomes even less reliable as a measure of size. A star may appear brighter not because it is larger, but because its light has been magnified by the curvature of space. Another star, equally large, may remain hidden, its light traveling in a direction that never reaches us. So the universe is not just vast, it is selective. It shows you some things clearly, while hiding others behind distance, dust, and the structure of space itself. And as you rest here, letting these ideas drift through your mind, you begin to see something deeper. Observation is not direct. What you perceive is shaped by layers, by time, by distance, and by the curvature of space, by processes that unfold far beyond immediate awareness. The stars you imagine, the giants, the hypergiants, exist within this complex framework, revealed only partially, never completely. Take another slow breath and let it go. Because as this journey continues, we will move closer to something even more fundamental, the realization that even the largest stars are only small pieces of a much greater structure, one that stretches far beyond individual objects, into the scale of galaxies themselves. At some point in this journey, something quietly shifts again. The stars you've been imagining, the ones so large they swallow planets, the ones that stretch across unimaginable distances, begin to feel smaller, not because they have changed, but because your perspective has. Because a star, no matter how large, is still just one object, and the universe does not stop at single objects. It builds structures, layers, systems that extend far beyond individual stars. And once you begin to see those larger patterns, even the biggest stars start to feel like small details within something much greater. Imagine a galaxy, a vast collection of stars, gas, dust, all bound together by gravity, slowly rotating over hundreds of millions of years. Our own galaxy, the Milky Way, contains hundreds of billions of stars. Some are small and quiet, others are massive and short-lived. Scattered among them, hidden in distant regions, are the giants you've been imagining. But within the scale of the galaxy, even those giants are just points of light. If you could step back, far beyond the stars themselves, and look at the Milky Way from a distance, you would not see individual objects clearly. You would see a glowing spiral, a soft band of light stretching across space, each star blending into the next. The largest stars, the most extreme ones, would not stand out. They would disappear into the whole. Now let that idea settle slowly. A star that could engulf our entire solar system, reduced to a single point, lost within a structure so vast that its individual scale becomes almost irrelevant. And yet, this does not make the star unimportant. It simply places it within a larger context. Because galaxies are not just collections of stars. They are systems where stars are born, evolve, and eventually die. The gas expelled from dying stars becomes the material for new ones. As the cycle continues, generation after generation, shaping the structure of the galaxy over time. So the largest stars, as extreme as they are part of this cycle. They are not separate from it. They are expressions of it. Take a slow breath and let it out gently, because as we move forward, the scale will expand once more, beyond galaxies, into something even larger, something that makes even entire galaxies feel small. If a galaxy already feels vast, something difficult to fully hold in your mind, then what comes next may feel almost impossible to imagine. Because galaxies do not exist alone. They gather, cluster, form enormous structures that stretch across millions of light years. And these clusters are bound together by gravity, connected through invisible filaments of matter, forming patterns that extend across the observable universe. Now imagine stepping back even further. A single galaxy becomes a point, a cluster becomes a node, and between them, there are vast regions of space, almost empty, where very little exists at all. These structures form what astronomers call the cosmic web, a network of galaxies and clusters connected across unimaginable distances. Within this web, everything is in motion, but on timescales so long that it feels almost still. Now think about the largest star again, a hypergiant, stretching across planetary orbits, burning brightly for a few million years before collapsing or exploding. Within the scale of the cosmic web, that star exists for a moment, in a location so small it becomes almost invisible, and yet it is still part of the structure, because the elements it creates, the energy it releases, contribute to the evolution of galaxies, and through them to the larger patterns of the universe. So even the biggest stars, the ones that challenge your imagination, are part of something far greater. Now let that idea rest gently in your mind. The universe is layered. Stars exist within galaxies. Galaxies exist within clusters. Clusters exist within a vast cosmic web, and each layer adds a new level of scale. a new level of perspective. Take another slow breath and let it go. And because as this journey continues, we will begin to move inward again, back towards something more personal, a quiet realization that connects all of this vastness back to you. After drifting through all of this scale, the giants, the collapsing cores, the galaxies and beyond, something quietly turns inward. Because everything you've been imagining, every massive star, every explosion, every cloud of gas expanding through space is not separate from you. It never was. The elements that make up your body did not begin here. They were not created on Earth. They were not formed in isolation. They were forged in stars, in environments far more extreme than anything you will ever experience. Carbon, formed in the cores of aging stars. Oxygen, built through nuclear fusion in massive stellar interiors. Iron, created in the final moments before collapse. And when those stars reach the end of their lives, they release those elements into space. Over time, that material mixed with other gas, slowly drifting, slowly cooling, until gravity pulled it together again. New stars formed, new planets formed, and eventually, in one small region of one galaxy, a planet formed where those elements could combine in new ways. And from that process, you emerged. Now pause for a moment and let that idea settle gently. Every atom in your body has a history that stretches back billions of years. Some of it was once part of a massive star, expanding, glowing, nearing its end. Some of it was ejected into space during an explosion, traveling across the galaxy before becoming part of something new. You are not just observing the universe, you are a continuation of it. And this connection is quiet, steady, always present. You don't feel it directly in your daily life. You don't notice it when you breathe or move or think. But it remains true, regardless of whether you focus on it or not. Take a slow breath in and let it out. Because the same oxygen moving through your lungs was once inside a star. The same carbon forming your body was once forged under immense pressure and heat. The same elements that make up distant giants are part of you now. And in that sense, the distance between you and the stars is not as large as it seems. After everything you've imagined, the immense size of stars, the scale of galaxies, the vast web stretching across the universe, there is a natural question that arises. Where do you fit into all of this? And the answer is quieter than you might expect. You exist in a small, calm region of a galaxy, orbiting an average star, on a planet where conditions happen to allow for life. There is nothing extreme about your location. It is not near the center of the galaxy. It is not in a region filled with massive stars or violent interactions. It is, in many ways, stable, and that stability matters. Because in regions where stars are too large, too close together, too unstable, life as you know it would not have the chance to develop. The radiation would be too intense, the gravitational interactions too chaotic, the lifespan of stars too short. So while the largest stars may capture your imagination, it is the smaller, quieter stars, like the sun, that provide the conditions needed for something like you to exist. Now let that idea rest gently. The universe contains extremes, objects that stretch beyond imagination, but it also contains balance, regions where things move more slowly, where processes unfold over long periods of time, where stability allows complexity to grow. You are part of that balance, not at the center of everything, not at the edge of something extraordinary, but in a place where the conditions are just right for awareness, for thought, for moments like this. Take another slow breath and let it go. Because in the end, the story of the biggest stars is not just about size. It is about contrast, the extremes that exist, and the quiet spaces in between, the vastness of the universe, and the small, calm places where you can simply exist and observe it. And as you continue drifting, you may begin to feel something simple, something steady, that you don't need to reach those stars or fully understand their scale to be connected to them. You already are. After everything you've explored, the giants, the explosions, the vast structures stretching across unimaginable distances, something quieter begins to emerge. A pattern, not in size, but in time. The universe does not rush. Stars take millions of years to form. Clouds of gas slowly collapse under gravity, heating, condensing, and eventually igniting. What feels like a sudden birth is actually a process that unfolds over timescales far beyond anything human experience can grasp. Even the larger stars, the ones that burn brightest and live fastest, still take time to grow. Their expansion into giants and hypergiants is not an instant transformation. It is gradual, unfolding over thousands, sometimes millions of years. And when they reach the end, when the balance breaks and collapse begins, the final explosion may happen in seconds, but only after a lifetime of slow change. Now let that idea settle. Everything you've imagined, every extreme, every vast structure is part of a process that moves at its own pace, not hurried, not forced, just steady, consistent, unfolding exactly as it must. And within that scale of time, your own life exists as a brief, quiet moment. But that does not make it insignificant. It simply places it within a larger rhythm. Because while stars take millions of years to evolve, you experience time differently. Moments feel immediate. Thoughts move quickly. Emotions rise and fall within seconds. And yet, when you step back, even slightly, when you allow your mind to drift outward, something begins to change. The urgency softens, and the need to resolve everything, to understand everything, begins to fade. Take a slow breath in and let it out gently. There is no need to rush. The universe isn't. At the beginning of this journey, you may have tried to understand everything precisely. The sizes, the distances, the numbers, trying to picture a star thousands of times larger than the sun, trying to imagine light taking hours to cross its surface. And at some point, your mind may have stopped trying, not because it couldn't understand, but because it didn't need to, because there is a difference between knowing and feeling. You don't need to hold the exact scale of a hypergiant in your mind to appreciate its existence. You don't need to calculate distances or compare radii. You can simply allow the idea to exist quietly in the background of your awareness. A star larger than anything you've ever experienced. That is enough. Now imagine letting go of the need to define it further. No measurements, no comparisons, just the presence of something vast, steady, and far beyond you. And as you let go, something else becomes possible. You begin to drift, not physically, but mentally. Your thoughts slow down, the edges of your awareness soften. The details that once demanded attention begin to fade into something more gentle, more open. The universe does not require you to fully understand it. It simply exists, and you are allowed to experience it in whatever way feels natural, even if that means not fully grasping its scale. Take another slow breath and let it go. Because in this space, where you are no longer trying to hold everything together, there is a kind of calm that begins to settle, a quiet acceptance that some things are too large to fully imagine. And that's okay, because the next step in this journey is not about expanding further. It is about slowing down and letting everything gently fade into stillness. As your mind continues to drift, something subtle begins to emerge, not from the stars themselves, but from the space between them. Because the universe is not only made of objects, stars, planets, galaxies. It is mostly made of emptiness, vast regions where there is almost nothing at all. No light, no structure, just space, stretching quietly in every direction. And within that emptiness, there is a kind of stillness. The largest stars you've imagined, as immense as they are, occupy only tiny regions within this vast expanse. Between them, there are distances so great that light takes years, centuries, sometimes thousands of years to cross. Now imagine that space, not as something cold or lonely, but as something calm, unmoving, silent, a place where nothing is being demanded, nothing is changing quickly, nothing is pulling for your attention, just stillness. And as you focus on that stillness, your own thoughts begin to reflect it. The movement slows, the need to think, to analyze, to follow every idea begins to fade, because in the space between stars, there is no urgency, and you can rest there. Take a slow breath in and let it out gently. Allow the idea of distance, of quiet, of emptiness to soften your awareness. There is nothing you need to reach, nothing you need to hold on to. The universe is not asking anything from you. It is simply there. And so are you. At the beginning, scale was everything. How big is the star? How far away is it? How long does light take to cross it? Your mind tried to measure, to compare, to build a picture that made sense. But now, something changes, because after a certain point, scale no longer needs to be held. You've already reached the edge of what can be imagined. You've moved beyond planets, beyond stars, beyond galaxies, into something much larger. And now, instead of continuing outward, you can gently release the need to define any of it. A star can simply be large. The universe can simply be vast. You don't need to calculate it. You don't need to hold numbers in your mind. You can let those details drift away, like distant points of light fading into the background. Now imagine this softly, a vast sky filled with stars, but you are no longer trying to focus on any single one. They are all there, existing quietly, without needing your attention, and you are simply present, observing, without effort. This is where the mind begins to rest, not because everything has been explained, but because nothing needs to be explained anymore. Take another slow breath and let it go, because in this space, where scale no longer matters, something else becomes more important. Stillness, a gentle awareness, without pressure, without urgency, without the need to reach for anything beyond this moment. And as you continue drifting, the stars themselves begin to fade slightly, not disappearing, but becoming part of a softer background where everything feels distant, calm, and quiet. At this point, the journey no longer feels like movement, and there are no more distances to cross, no more scales to stretch your imagination. The stars are still there, the vastness is still there, but something about the way you experience it has softened. Everything becomes light, not the intense, burning light of giant stars, not the blinding flash of a supernova, but a gentle, distant glow. The kind of light that doesn't demand attention, doesn't overwhelm, just quietly exists in the background. Imagine looking up at the night sky, but without focusing on any one star. Your gaze is soft, unfixed, allowing the entire sky to blend into a calm, steady field of faint light. No single point stands out. No detail needs to be followed. Just a quiet presence, spread evenly across your awareness. And as you rest in that space, your thoughts begin to mirror it. Instead of sharp ideas, you notice softer impressions. Instead of clear images, you feel a sense of openness. The boundaries between one thought and the next begin to blur, just like the stars blending into the night sky. Nothing needs to be held. Nothing needs to be understood. Everything simply is. Take a slow breath in and let it out gently. The universe is still vast, still filled with objects beyond imagination, but you are no longer trying to reach them. You are simply allowing them to exist at a distance, without effort. And in that distance, there is calm. Earlier in this journey, there was a sense of direction, moving from one star to another, from one idea to the next, building an understanding step by step. But now, direction fades. There is nowhere to go. No next destination. Just space, open and quiet, extending in all directions at once. And instead of moving through it, you begin to drift within it. Not forward, not backward, just gently suspended. Imagine floating in a vast, dark expanse with no need to orient yourself. No up or down, no left or right, no sense of distance or destination. Just a soft awareness of being, surrounded by something infinitely larger, yet completely still. And as you drift, your mind follows. Thoughts no longer form in clear sequences. They appear briefly, then fade, like distant points of light blinking in and out of awareness. There is no need to follow them, no need to hold on to them. They come and they go, just like everything else. Take another slow breath and let it go. Because in this state, where direction no longer matters, something deeper begins to settle in a sense of rest. Not the kind of rest that comes from stopping after effort, but a natural stillness where nothing is being asked of you at all. The universe continues, stars evolve, galaxies move, but none of it requires your attention right now. You are simply here, drifting, quiet, at ease. And as you continue, even the idea of drifting begins to soften, becoming lighter, slower, until it almost disappears into the background, leaving only a gentle, steady calm. By now, even the idea of the universe has softened. It is still there, vast, quiet, stretching far beyond anything you could reach, but you are no longer holding it in your mind the way you were before. The details have faded. The structure has dissolved into something much simpler, just space and a gentle awareness within it. Or you may notice your thoughts becoming slower, more distant, like echoes rather than clear voices. They appear briefly, then dissolve before fully forming. There is no need to follow them, no need to complete them. They are allowed to remain unfinished. Now imagine this softly. You are at the edge of awareness, not fully thinking, not fully asleep, just resting in a space where everything is quiet. The stars are no longer objects to understand. They are just part of the background, like distant points of light that no longer ask for your attention. And even those points of light begin to dim slightly, not disappearing, just becoming less defined. The universe remains, but your connection to it becomes lighter, more relaxed, less focused. Take a slow breath in and let it out gently. There is nothing left to explore and nothing left to figure out. Only this moment, quiet, open, still. As you rest here, the final shift begins. The universe that once felt so vast, so detailed, so filled with incredible extremes begins to fade into something softer. Not because it is gone, but because your attention is gently releasing it. The stars, the galaxies, the immense scales you imagined, all drift further into the background, like a distant memory, still present, but no longer vivid. And in their place, there's something even simpler. Darkness. Not an empty darkness, not something cold or isolating, but a calm, quiet space where nothing is defined. A place where your mind no longer needs to hold images or ideas or scale, just stillness. Now imagine that darkness surrounding you, gently, evenly, without pressure. It doesn't pull you, it doesn't push you, it simply exists, allowing you to rest within it. Your thoughts grow quieter, your awareness softens, even the sense of being here begins to dissolve, becoming less specific, less anchored. Take another slow breath and let it go. Because at this point, there is nothing left to do. No more stars to imagine, no more distances to cross, no more ideas to follow, only a quiet, steady fading into rest. And as everything becomes softer, slower, quieter, you may begin to feel yourself drifting, not through space, not through time, but into something even deeper, a gentle, natural, and peaceful sleep. There is almost nothing left now, only the faintest trace of what once filled your mind. The stars you imagined, the vast giants, the distant lights, the silent explosions. All of them are still part of the universe, but they are no longer part of your focus. They drift far away, like echoes that have already faded, and in their place, there is quiet, a soft, steady quiet that does not ask for attention, does not require understanding, does not need to be held. You are no longer observing the universe, you are simply resting within it. Thoughts may still appear, very gently, like small ripples on still water, but they do not stay. They do not grow. They rise and then dissolve, leaving the surface calm again. Nothing needs to continue. Nothing needs to be completed. Take a slow breath in and let it out softly. Even the breath itself begins to feel lighter, more natural, less something you are doing, and more something that is simply happening. And somewhere in the background, beyond awareness, the universe continues. Stars burn, galaxies move, light travels across unimaginable distances. But none of that needs you right now. You are allowed to rest. Now the quiet deepens. There is no more movement, no more direction, no more sense of drifting. Even that gentle motion fades into something more still, more grounded, more peaceful. Imagine sinking, not downward, not into anything physical, but into a deeper layer of calm, a place where everything slows to the point where it almost stops. Your thoughts are no longer forming clearly. Your awareness softens, becoming wider, less focused, more open. And in that openness, there is nothing to hold on to. No images, no words. just a soft, quiet presence. Take another slow breath and let it go. The body relaxes without effort, and the mind follows, releasing the last bits of tension, the last traces of active thinking. Even the idea of listening begins to fade, becoming something distant, something unnecessary. You are not trying to sleep. Sleep is simply approaching, naturally, gently, without resistance. And as it does, everything becomes softer, quieter, more still, until there is almost nothing left to notice at all. Just a calm, steady, peaceful darkness, waiting without expectation. As you slowly, gently drift the rest of the way into sleep, at this stage, even silence begins to feel softer. Not the kind of silence that feels empty, but the kind that feels full, steady, and gently supportive, and the kind of silence that doesn't surround you, but holds you, like something patient, something that has always been there, long before your thoughts began, and long after they fade. There are no more stars to follow now, no more distant giants to imagine, no more vast distances to stretch your mind. All of that has already passed through your awareness, and now it has gently drifted away, like light that has already traveled its path. What remains is stillness. Your mind is no longer trying to build images, no longer trying to understand, no longer reaching outward. Instead, it begins to settle inward, slowly, naturally, without effort. Thoughts, if they appear at all, are faint, barely formed, like whispers that never fully become sound. They don't stay long enough to matter. They rise, soften, and disappear, leaving no trace behind. And with each moment, the space between thoughts grows wider, calmer, quieter. Take a slow breath in and let it fall out naturally. There is no need to control it. Your body already knows what to do. And as your breathing becomes softer, your awareness follows. The edges of your thoughts blur, the sense of time loosens, and the quiet becomes deeper, more complete. Even the idea of listening begins to fade. You are no longer actively following words. They simply pass through gently, like distant ripples that do not disturb the surface. Now imagine this softly, a calm, endless night, with no need to look up, no need to notice anything at all. The sky is there, but it no longer asks for your attention. It simply exists, quietly, as everything else fades, and you are part of that quiet, not separate from it, not observing it, just resting within it. Take another slow breath and let it go. There is nothing left to reach, nothing left to understand, only this steady, gentle descent into stillness, where everything becomes lighter, slower, softer, until even the idea of becoming still disappears, and there is only silence. Now, you may begin to notice something subtle. Thoughts are no longer forming the way they did before. There are no clear sentences, no structured ideas, no images that hold their shape. Instead, there is something softer, less defined, like a quiet space where thoughts might appear, but don't quite take form. And that is exactly where you want to be, because this is the space just before sleep, a place where the mind no longer needs to organize, no longer needs to follow, no longer needs to continue anything at all. Everything unfinished can remain unfinished. Everything incomplete can stay that way. There's no need to resolve anything. Now imagine your awareness as something very light, almost weightless, gently floating, not in space, but in a calm, undefined stillness. There is no direction, no movement, just a soft presence, barely there, yet completely at ease. Your breathing continues, slow, natural, effortless. Your body feels heavier, but your mind feels lighter. And somewhere between those two, There is a perfect balance. Take a slow breath in and let it out. Even that breath feels quieter now, less noticeable, more distant, and as it fades, so does everything else. The need to think fades. The sense of time fades. The awareness of your surroundings fades. All that remains is a gentle, steady calm that continues without effort. And now allow yourself to drift just a little further. No pushing, no trying, just letting go. One small layer at a time. Thoughts become fragments. Fragments become impressions. Impressions become nothing at all. And in that nothing, there is peace, a deep, quiet peace that does not need to be understood, only experienced. Take one last slow breath and let it go completely. Because now, you are no longer following anything, no longer listening, no longer imagining. You are simply resting. And as everything softens, fades, and dissolves, sleep arrives, gently, naturally, exactly when it's ready, and you drift effortlessly into it. At this point, there is almost nothing left to hold on to. Not the stars, not the universe, not even the gentle drifting you once followed. Everything that once filled your awareness has softened, thinned out, and quietly stepped back, leaving only the faintest trace of presence. You may notice that even your sense of being here is changing. It is no longer sharp, no longer defined. It feels distant, like something you could reach for, but don't need to. And that distance is peaceful, because there is no effort left. No need to stay awake. No need to follow anything further. Just a quiet, steady fading. Now imagine this very softly. A single point of light, far away, barely visible, slowly dimming, not because it is disappearing, but because your attention is gently moving away from it. You are not losing anything. You are simply letting it go. And as that final point of light fades, the space around it becomes smooth, even, uninterrupted. No edges, no shapes, no movement, but just calm. Take a slow breath in and let it fall away. Even the breath feels distant now, like something happening far away, without needing your attention. Your body is resting deeply. Your mind is no longer forming clear thoughts, and your awareness is becoming lighter, quieter, softer. You are not trying to sleep. Sleep is already here. You are simply allowing yourself to settle into it. Without resistance, without effort, everything that needed to happen has already happened. There is nothing left to do. Now, even the idea of drifting begins to disappear. There is no movement left, no direction, no sense of going anywhere. Only a soft, endless stillness. The universe, as vast as it is, no longer feels distant because it is no longer something you are thinking about. It has become part of the background, and the background itself is fading into something even simpler. A quiet, gentle darkness, not empty, not cold, just calm. Now imagine yourself resting within that calm, without needing to define it, without needing to understand it. You are not separate from it, and you are not observing it. You are simply part of it. And as you rest there, everything continues to soften. The last remaining thoughts fade before they fully form. The last sense of awareness becomes lighter, more distant. Even the feeling of time begins to disappear. There is no before, no after. Just this quiet, steady stillness. Take one more slow breath and let it go completely. And as that breath fades, there is nothing left to follow, nothing left to hold, nothing left to notice. Only a deep, natural, peaceful rest that carries you the rest of the way into sleep. There is nothing left now, only the quietest sense of being, Not a clear awareness, not a defined thought, just a gentle presence that lingers, like the last warmth of light after it has already faded from the sky. You are no longer following anything, no words, no images, no ideas. Even the memory of the stars, the vast giants, the endless universe has softened into something distant, almost gone, like a dream you can't quite recall. And that is exactly where you need to be, because this is the space where sleep fully takes over, not suddenly, not forcefully, but gently, gradually, as if the mind itself is closing its eyes. Now imagine this very quietly, a surface of perfectly still water, no ripples, no movement, reflecting nothing, because there is nothing left to reflect. The surface is calm, undisturbed, complete, and your mind becomes like that surface. No thoughts rising, no patterns forming, just stillness. Take a slow breath in and let it fall away. Even the breath is barely noticeable now. It happens on its own, soft, steady, without your attention. Your body is completely at rest. Your mind has released everything. And what remains is silence. Not empty silence, but a full, peaceful quiet that holds you without asking anything in return. There is no need to stay aware of this moment, no need to remember it, no need to follow it any further, because you are already where you need to be. And as everything continues to soften, the final layer of awareness begins to fade, gently, naturally, effortlessly. Now, there is only rest. No more journey, no more thoughts, no more need to understand anything at all. Everything you needed to hear has already passed. Everything you needed to feel has already settled. And now, your mind is free to let go completely. Imagine yourself surrounded by a calm, endless night. Not something distant, but something close, soft, comforting. There are no edges, no boundaries, nothing that requires your attention. Just a quiet space where you can finally stop holding on. Your breathing is slow, your body is still, your mind is quiet, and sleep is no longer something you are waiting for. It is already here, gently, steadily, wrapping around your awareness, carrying you deeper into a place where there are no thoughts, no effort, no need to stay awake. And as you drift further and further, everything fades into a soft, peaceful darkness where nothing disturbs you, nothing reaches you, nothing needs you, only rest, deep, natural, complete rest. So now, you can let go completely and allow yourself to fall softly into sleep. Good night. As you rest here, gently carried by the quiet rhythm of your breath, remember that everything you've experienced tonight, the vast stars, the endless space, the slow, peaceful drifting, does not need to stay in your mind. It can fade, just like the light of distant stars. It can softly disappear into the background, leaving behind only calm. If this journey brought you even a small sense of peace, you can support this space by leaving a like or subscribing, so these quiet moments can continue to reach others who need rest, just like you. There's nothing else you need to do now. No need to finish anything, no need to stay awake. Just let the stillness remain and allow yourself to drift deeper into a gentle, natural sleep. And whenever you return, the universe will still be here, quiet, vast, and waiting for you. Good night, and sleep well.